A strange radio signal from deep space baffles scientists. We received a strange signal from across the galaxy, and astronomers are struggling to understand what it means. They know what's emitting the signals. It's a neutron star named ASKAP, J1935 plus 2148 for short, located in the plane of the Milky Way, some 15,820 light years from our Earth. However, the signals themselves are like none we've ever seen before, they said. The star goes through periods of strong pulses, periods of weak pulses, and periods of no pulses at all. What we don't know, according to a team led by astrophysicist Manisha Kaleb of the University of Sydney, Australia, is why. The strange object poses a fascinating challenge to our models of neutron star evolution, which, let's be honest, he says, are currently pretty far from complete. A neutron star is what's left after a star within a certain mass range dies, between about 8 and 30 times the mass of our sun. The star's outer material is blasted off into space, culminating in a supernova explosion, and the leftover core of the star collapses under gravity, forming an ultra-dense object up to 2.3 times the mass of the sun, in a sphere just 20 kilometers across, or 12 miles across. So that's very small, as we can understand. The neutron star that results can then present in a variety of ways. And there's a base neutron star which just hangs out, not doing a great deal. There's a pulsar which sweeps beams of radio emission from its poles as it rotates, flashing like a cosmic lighthouse. And there is a magnetar, a neutron star with extremely powerful magnetic field, which jerks and erupts as the outward pull of that magnetic field wars with the gravity keeping the star together. There can also be some rare crossovers between the neutron star types, suggesting that they may be different stages of neutron star evolution. Generally, however, pulsars, magnetars, and neutron stars tend to behave in relatively predictable ways. And this one here, ASKAP, does not behave in ways that are normal for a neutron star of any established kind. It was first identified serendipitously during observations of a different target, and follow-up observations were made using the Australian Square Kilometre Array Pathfinder ASCAP and the Meerkat Radio Telescope in South Africa. The researchers also dove into previous ASKAP observations covering the same patch of sky, and they found that this has a regular period of pulses of 53.8 minutes, but that seems to be the only normal thing about this pulsation. One pulsation mode they found was extremely bright with highly linear polarization, but then it would subside completely with no measurable pulsations for a long period. And finally, the star was detected resuming its pulsation activity at a whopping 26 times fainter than its earlier bright mode, and with light that is circularly polarized. In recent years, several strange objects have been found spitting out repeated signals in the southern sky. Although they do not all behave in the same way, they could be related. Gleam X is another object near the galactic center that is caught spitting out bizarrely bright flashes for just 3 months before falling quiet again. GPM J1839 was found to behave like a bizarrely slow pulsar, emitting 5-minute bursts of radio waves every 22 minutes. And JCRT is a pulsating object near the galactic center with a period of 77 minutes. We don't know for a certainty what any of these objects are, but neutron stars seem likely. And ASKAP, Caleb and her colleagues suggest, could be a sort of bridge between the different states. The differences between its pulsation modes are likely connected to magnetospheric changes and processes, suggesting that all the objects belong to a new class of magnetars, possibly as they evolve into pulsars. ASKAP is probably part of an older population of magnetars with log spin periods and low X-ray luminosities, but magnetized enough to be able to produce coherent radio emissions, the researcher writes in their papers. It's important that we probe this hitherto unexplored region of the neutron star parameter space to get a complete picture of the evolution of neutron stars, and this may be an important source to do so. The findings have been published in Nature Astronomy, and this is on Science Alert by Michelle Starr. So there's still a lot of things about space, obviously, we don't know. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.